Okay, just take a look around you for a second. Everything that's plugged in, every device with a battery, it's all powered by this silent battle that's been going on for over 100 years. Today, we're going to decode the two sides of that fight, AC and DC. These are the two types of electricity that literally run your entire world.
Think about something you do every single day, plugging in your phone. But have you ever stopped and wondered what that little block, that little box on the end of the cord is actually doing? Well, it turns out that simple little thing is the key to understanding, the entire world of electricity. And that's exactly what we're going to get into.
All right, first up, let's talk about direct current, or as you probably know it, DC. The name itself gives you a massive clue about what makes it special. Just think of it as the most straightforward, no-nonsense type of power out there. So here's the absolute key. Direct current is, it's exactly what it sounds like. The electricity flows in just one, steady, unwavering direction. It's like a constant, reliable push of energy, always moving forward, never turning back.
A perfect way to picture this is a simple garden hose. You turn on the faucet, and the water just flows straight out one end in a constant, direct stream. That is DC power in a nutshell. It's simple, it's predictable, and it's direct.
So what's the main takeaway for DC? Well, because it flows in just one direction, it's absolutely perfect for things that need to store power, like all your batteries and solar panels. And that super stable, consistent current is exactly what sensitive electronics, like your phone, your laptop, what they need to work without, getting totally fried. It's just a nice, gentle, predictable power. Okay, now let's totally switch gears and talk about its counterpart, alternating current, or AC. So if DC is that calm one-way street, AC is a frantic, two-way superhighway. And this is where things get pretty wild. Unlike that calm, steady flow of DC, alternating current is constantly, and I mean constantly, flipping its direction. We're talking about the electricity reversing its course, back and forth 60 times every single second, here in the US at least. It literally never stops moving.
A really great way to think about this is a power saw. The blade doesn't just push forward in one direction, right? It moves back and forth, super rapidly, to get the job done. That constant reversal is the absolute essence of alternating current.
So AC is the power that comes pouring out of your wall sockets. It's generated in these enormous power plants, and it's what runs all the big, power-hungry stuff in your house, like your fridge or your washing machine. But its real superpower, the reason it basically won the war of the currents back in the day, is its incredible ability to travel hundreds and hundreds of miles with very little energy loss.
Okay, so we've met our two players, AC and DC. Now let's put them side by side to really see how they stack up against each other.
When you boil it all down, this is it. This is the fundamental difference. AC alternates and DC is direct. And this one simple difference in how the electricity flows is what leads to all the completely different ways that we use them.
See, this difference in flow has huge consequences. AC comes from these massive power plants and is the undisputed champion of cross-country travel. DC, on the other hand, comes from smaller sources, like batteries and solar panels, and it provides that gentle, stable power needed for your delicate gadgets. They're basically two different tools for two very different jobs.
So this brings us to the really big question, right? If they're so different, why do we rely on both of them every single day? Why not just pick one and stick with it?
Well, the answer really starts all the way back at the power plant. It is just way more efficient to transport AC power over hundreds of miles to get it to our cities and homes. It loses less energy along the way, which makes it absolutely perfect for our national power grid. The thing is, once that power gets to your house, we've got a problem. Your smartphone, your laptop, your tablet, their tiny, complex little computer chips just can't handle the back and forth chaos of AC. It would completely destroy them. They need that calm, stable, one-way flow that only DC can provide.
And that brings us right back to our little mystery box. That charger is actually a brilliant little device called an AC-DC adapter. Its one job, its entire purpose in life, is to act as a translator. It takes that powerful, long-distance AC power from your wall and converts it into the safe, stable DC power that your device's battery can actually use.
So really, it's a simple three-step journey every time you charge something. You've got high-voltage AC traveling from the power plant to your wall. Then your adapter steps in and does its thing, converting it to safe, low-voltage DC. And finally, that gentle DC power flows right into your device. That little bit of magic happens every single time you plug something in.
So here's a final thought to leave you with. For over a century, AC has been the undisputed king, mainly because we needed to move power across this massive grid. But now, think about the rise of solar panels on our roofs, powerful batteries in our homes, in our cars. That is all native DC power. So as we start generating and storing more of our electricity locally, are we slowly shifting back towards a DC-powered world? The great electricity war might not be over after all. It's something to think about the next time you plug in your phone.